evolution works. The theory and the science don't match. I'm giving you a summary of all the first section. The theory and the science don't match. In other words, you cannot substantiate the theory of creatures evolving from a single organism all the way to what we have now. You can't even do it in the laboratory, let alone in a puddle on the surface of the planet. You can't do it. And if you understand how many evolutionists there is motivation to do it.
Oh, yeah, right.
I mean, if they could have some proof that evolution happens, they would love it. But even with all the grant money and all the laboratories and all the technology and all the abilities, isn't it saying something that they still can't do it? That's big. So we're going to step away from that, and now we're going to go into a phase of we're going to look at the world around us. And we're going to say, so what does the planet tell us about creation and evolution? What do the rocks say? All right? We're going to take a look at the world and the wonderful geologic record. Okay? Quick review. We talked about microevolution, which is really just adaptation. It's where you have creatures that adjust to their environment in order to survive better. Okay? If macroevolution is true, there ought to be an unimaginably large numbers of transitional forms. Like some of those pictures I had, right? There should be creatures in the rocks that are half frog and half mole. We should find those. Because they didn't just theory of evolution. They didn't just exist for a year. They existed for hundreds of thousands, if not millions of years. The transitional forms. Remember, we're talking about millions of years. Surely there would be fossils of those transitional forms. But we don't find them. When we look at, I'm going to show you lots of pictures of fossils. When we look at the fossils, it's easy to identify exactly what they are. You'll be surprised. You'll be like, that fossil, oh, that's a bird. Oh, that's a frog. That is a sloth. You can tell. Just the common, everyday people, non-scientists, will be able to tell exactly what the fossils are. But you never see something you go, well, it's got a tail like an alligator, but it's got a head like a chimpanzee. And it's got wings. There aren't any of those. They don't exist in all the fossil records. So these transitional forms, they're not there in the geologic column. They're just not there. The theory of evolution is based on the concept that microevolutionary or adaptive changes will be found in organisms and add up to macroevolution. But it's just not there. We've seen that this is not supported in the laboratory, and I'm telling you, it's not in the geologic column either. It's just not there. So let's talk about the geologic column. There are three kinds of rocks in the world. Can you tell me what kind, but three major kinds of rock? Here's the first one. Where did it go? Yeah, here. Looks like, looks a lot like Hawaii. Comes out of a volcano. So that's igneous rock. Rock made in volcanoes. Okay? That's igneous. Then there's another kind. I don't have any here. Can you believe that? Well, this is kind of it. We'll go with this. Yeah. Yeah, this one. This one, definitely. What kind of rock is this?
Granite.
There's granite. Yeah. And here is something called conglomerate. If you look closely, what's this rock made of?
Lots of different rocks.
Lots of little rocks. Metamorphic rock is rock that has been under intense heat and pressure and is kind of like melted. Kind of like if you left a box of chocolates in the back window of your car and came back, what would it be?
A mess.
It'd be one big chocolate. It'd just be kind of together. That's metamorphic rock. And then there's one more kind. Anybody? Sedimentary. We were on vacation this summer, and we stopped at a hotel, and next door they were digging up for a building, and I just happened to walk by it, and I found this piece of shale. It's full, absolutely chock full of little creatures. Absolutely amazing. This is sedimentary rock.
Where did you get them?
It was in Hawkesbury, Ontario. Yeah, but you know what? Everywhere I go, I find fossils. Everywhere. So this is sedimentary rock. What do you notice about it? Layers. Most of the world is covered with sedimentary rock. Like upwards of 80% of the world, sedimentary rock. How do you make igneous rock with a volcano? How do you make metamorphic rock? Well, you have subduction and you have heat and pressure. It's rock that's formed deep in the Earth's crust. How do you get sedimentary rock?
Layers.
Yeah, so it's rock that's broken up into little pieces and either washed or blown somewhere, and then it's left to settle, and gradually it forms into a composite. Now, if 80% of the world is sedimentary rock, what does that mean?
It's all underwater.
We just have to say that that indicates that the entire planet has huge amounts of rock that was made with water. Now wind can distribute the pieces, but it's going to be water that literally gets them together, washes them together, and then as the water slowly is eliminated, it'll cement together. Over 80% of the planet is made with water. Now, how much of the planet is covered with water right now?
70%.
Yeah, about 70%. Yeah. So if we go below that water, what's under there? Sedimentary rock or igneous or metamorphic? Also sedimentary. So it's a no-brainer. Here I have 75%. On the world's surface, up to 1.5 miles deep, like the skin on an extra crispy chicken, is sedimentary rock. And I thought I should show you some extra crispy chicken. Okay? Now, in this sedimentary rock, anybody know what that is? It's the Grand Canyon. It is one of the most spectacular geologic sites.
And there's not a picture that does it justice.
Oh, none. So what is in this sedimentary rock spread around the world are billions and gazillions of fossils. All kinds of fossils in distinct layers of eroded materials deposited by water. The world was literally created. What could have created the Grand Canyon? Oh, wait. You know what? We tend to think of the Grand Canyon as the space, and that is really remarkable. And it's really cool. But you know, this is just a cut into what goes for miles in every direction, the plateau. And that whole plateau, if we were to dig down in it, it will have the same layers as the Grand Canyon. So when we look at this, let's expand our mind and think these layers go for miles and miles and miles and miles, all deposited by water, layer by layer, with copious amounts of fossils in them. Something really big had to do that.
Oh, but one river just carved all that out, didn't it?
I'm not talking so much about the carving as I am, oh, there's your crispy chicken. I'm talking about all that material being placed there. And that's just in the Colorado Plateau. You'll find if we had an erosion event that cut down through the center of any flat area, you're going to find layers just like that. And you're going to find fossils. I don't care where you dig. You dig, you're going to find fossils. They're all over. They've been distributed around the world. Yeah, so what I say here is places like the Grand Canyon really just reveal what's below our feet, all around the world. Layer after layer of sedimentary rock containing the record of Earth's past. So, let me tell you about the geologic column. There you have kind of a geologic column. You have the very simple creatures, then jawless fish, then jawed fish, amphibians, reptiles, birds, dinosaurs, early mammals, monkeys, apes, modern mammals. And evolutionists would love for you to learn and agree with their story. Their story is, this is the first layer laid down. I go with that. It has the earliest living creatures. Not sure about that. And then as time went on, layers got layered upon layer upon layer upon layer upon layer, and we worked up to more and more complex, and finally the mammals that we live amongst today. They'll put this together as the Paleozoic, the old animal life, that's the deepest one, middle animal life, Mesozoic, and Cenozoic. Just big words to talk about different sections of the geologic column. So, question. Where would I find that entire column in the world? It's nowhere to be found. You cannot find the complete column anywhere. This is a cut and paste column where they found, a place where there's these creatures, and then there's a place where there's these creatures, and there were overlaps. So this is a composite picture of the Earth based on the understanding or the thought pattern that the oldest creatures are buried first. Okay? So the evolutionary explanation of the geologic column, the fossil record found in the geologic column around the Earth is interpreted as documentary evidence of the theory of evolution. Remember when I had the soccer ball up? And I was asking you what happened? We came up with all kinds of things, didn't we? I mean, a soccer ball in the air could have been hit, could have been punched, could be falling, could be sitting on a blue floor. We had to make some assumptions. So the evolutionary concept is with the assumption that this is the process of evolution. And so that's one of the first things I'm going to ask you. Is it? Is this evidence that one creature turned into another, turned into another, turned into another?
No, it's just how they were buried.
This is, well said. This is how they were buried. Just like the balls in the air, doesn't say anything about which direction it's going. This is just how they were buried. It doesn't say anything about who became whom. In fact, there are lots of questions we can ask of the geologic column, and that's what we're going to be doing tonight. There's a doctrine, and yes, it sounds like I'm talking about a church, but it's a doctrine of evolution, and it's the theory of uniformitarianism, meaning that everything has always been as it is now. Nothing in the past is different than what's going on today. The rates, the concentrations, everything that's going on in our world now is how the world has always been. What do you think of that?
Well, you showed us yesterday that couldn't be accurate.
If that was the case, there's no possible way we could have the geologic column spread around the world. Something global has had to happen in the past for us to get the geologic column. You can't explain the geologic column by the things that are going on in our world now. Fossilization is not taking place at any appreciable rate. I mean, I've seen whales, big creatures, big bones, not becoming fossils, but rotting, bloating, getting eaten, getting distributed, getting washed away, getting dissolved, and no whale skeleton afterwards. I mean, if you want to have a bulk to fossilize. And yet, there are fossilized whales. So, something different happened in the past than's happening today. But there's something that's even more incredible. Fossil fuels. How much fossil fuel is in our world? Don't tell me, none of us really know, but it's an immense amount. I just heard today that China uses 12 billion barrels of oil a day? Maybe I've got that wrong. That just seems unbelievable. It's a lot. How can we do that day after day after day after day? What is fossil fuel? Fossil fuel are plants, some animals mixed in there, that have been under intense heat and pressure to the point where they got squashed into just carbon chains. That's why we call it, what do we call gas and oils? Hydrocarbons, that's right. All that's left is carbon chains. But the ratio is like 10 to 12, 12 to 1. So you would need 12 feet of plant and animal matter to squash it into 1 foot of coal or oil. And there are vast beds of coal. Okay, so something big happened in the past that's not happening today to make all that coal and all that natural gas and all those huge reserves of oil. You see what I'm saying? Uniformitarianism is a doctrine, though, because they have to think that what goes on today always happened, and that's how they explain the past. You see, if something different happened in the past, then that would open the door for the flood. And if the flood is true, which all the sedimentary rock backs up, if the flood is true, that really puts evolution in a bind.
Right.
Because that's chapter 6 and 7 in the Bible. And if chapter 6 and 7 are right and true and unnatural, can I say that? Miraculous, then that puts a big light on Genesis 1, 2, and 3. So what is happening now has always been. Let's see how that plays out in evolutionary theology. Okay, so let's have some facts about the geologic column. The overall fossil order and strata sequence have been clearly identified. Like, you can go to the field and you find these creatures in this layer, these creatures in this layer, and no creationist is going to argue that no, you got the layers backwards. It's pretty well creationists, evolutionists, it's clearly established. No one's arguing about who's where as far as the sequence. There are 6 thick sequences of sedimentary rock known as the megasequences, and can be traced across North America and beyond to other continents. So here's something that's also been clearly accepted and established. The geologic column is a worldwide phenomenon. So no local flood can explain it. That's important, because that's one of the things that is proposed. Oh, it's just a local flood. No, it can't be. Because you can find those layers here, and you find the layers on the other side of the world, and north and south. You find it everywhere. So it had to be a one-time worldwide event. Otherwise it wouldn't line up. That makes sense, right? Yes. Isn't that incredible? You go to the rocks, and there's so much evidence for something we call Noah's flood. The layers show smooth, distinct boundaries. So what's the significance? Okay, evolutionists say the layers were deposited, and then billions of years later, another layer was deposited. Then a billion years later, another layer was deposited. That's why you have to have time for the animals to evolve before the next layer comes. See? That's their answer to no transitionary individuals. Okay, here we have the frogs, and then the frogs evolved into lizards, and then we had this deposition of another layer, and see, now we have the lizards. And then they were running on that layer for a billion years while they turned into birds, and then you have another layer. Oh, look, here's the birds. So they think millions of years between the layers, but there's a problem with that, and it's called erosion. The layers that you find in the geologic column are flat and smooth. If there was a million years of erosion, what would the layer's surface look like? It would be eroded, there would be pits, there would be dissolving, there would be all kinds of erosion, and so the next layer would be on an uneven surface. But you can trace these layers for miles in every direction, and they're flat and smooth. What does that mean? They were laid down quickly in succession. Does that make sense?
Yes.
That's a problem for an evolutionist. Because they're like, no, there has to be millions of years between the frogs and the lizards and the birds. If they were all laid down in a quick succession, evolution couldn't possibly have enough time to progress. Do you get the sense that all these evolutionary ideas are dependent upon each other with no scientific basis? And if one piece falls, they all fall. If we could show that the geologic column was laid down quickly in one global event, it blows evolution out of the water. It makes it, once again, how many times have we done this with all the things we've talked about? It makes it an impossibility. Miles and miles of flat, look at this. You can trace, and this is, I think, about 15 miles. You can trace this layer right across.
All the way.
Have you ever seen are they called buttes? Up on the Colorado Plateau? You see this big land mass that goes up. And 100 miles away, you see another butte over here. And if you stand far enough away, you can see the layer in both. You know, what happened to all the material between these two buttes? Because these buttes didn't push up.
Erosion.
It's that everything that was between them is gone. Eroded. And yet, the layers line up. So, in your mind, you can think at one time, before it was eroded away, that layer went all the way across. Ah, evidence for creation. Okay, fossils show distinct and consistent ordering. They're not making up that the simplest forms are at the bottom. They're not making that up. It's legit. Okay? More complex forms at the top. That's legit. Their explanation for how it happened is not. In general, the layers contain larger, more complex organisms as you move to the top. Absolutely. Dinosaur fossils in the geologic column appear abruptly. It's called the Cambrian explosion. No dinosaurs, and then all the dinosaurs. Overnight. Ah. Evolutionary speaking, that is like, how in the world? It would take billions, literally it would take billions and billions of years to make a T-Rex out of a toad, you know? I mean, come on! But it just appears, and it exists for, in their minds, millions of years, right? And then it disappears. And the T-Rex at the very bottom and the T-Rex at the top are identical. So, it came out of nowhere, like all of a sudden, blink, dinosaurs everywhere. Existed for millions of years, and then, blink, they're gone, all gone. No change in between. Now we have some issues with dinosaurs as creationists. I expect God just made them and sin turned them into nasty creatures. Not all dinosaurs were nasty, you know. The average size of dinosaurs was the size of a sheep. We just get fed T-Rex, 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 Brontosaurus, Seismosaurus. We get fed all these huge, big, violent creatures. But they are only a few of the dinosaurs. Most of the dinosaurs were little. More like lizards than anything else. We've just been fed what the media wants, the media or the scientists want us to be fed with. So, once again, if something's true, you don't need to campaign for it.
Where did they get the bones for the dinosaurs?
The bones are all over the place. There's a place called Badlands
They
in
put them
Alberta.
together and make them look like dinosaurs, is that what you're saying?
No, they're legit bones.
No,
They're legitimate bones, and when they put them together, they do their very best scientific work to put them together. So, no, I trust those, absolutely. I don't trust the actual look of a T-Rex, because they're just guessing.
The outside, you mean?
Yeah, the outside. Like when they take the bones and put flesh and scales on it, some of them they'll put feathers on. I don't trust that. I'm not sure about that, because we're guessing. You know, But the actual bones, they're legit.
How do they know what they look like?
They're making it up, you say.
Well, with the bones, you can tell where bones used to fit together. You can figure out the cartilage that would have been there, and you can actually articulate a skeleton having never seen the creature before.
The tar pits, they're
Okay.
pretty complete.
Yes, and that's a fantastic point. There are places where you have almost complete dinosaurs, like skin, organs, and other pieces as well. So that's a very good point. But not all kinds of dinosaurs. And so what they do a lot of times is they will say, well, this worked for the Triceratops, let's try it on the Allosaurus. Yeah, so good.
Well, they can take like if they find a tooth or a bone, they can take the moral from that. And, you know, with the tests that the scientists do, they can tell whether there was something like feathers on them or what type of skin it was.
Not necessarily. I'm going to hold back from that. I don't think so.
Sure can.
Yeah, because the genetics is mostly scrambled. They do find, and this just blows the mind, they have found bones with blood in the marrow.
Oh, yeah.
Center. But the red blood cells are so dried out or decomposed that they've not been able to extract complete DNA. Sections, yeah, but not enough to really know anything. Okay, so I want to talk about fossilization. How does something become a fossil? Okay? Well, what has to happen? So here's the evolutionary explanation for the formation of the geologic column. Over time, plants and animals died, were buried in events mirroring the catastrophes we have today, forming the geologic column. So hurricane would go through, animal would die and get buried by some mud that slid down. Okay? I mean, this is legit. A volcano happens, like Vesuvius, and people are buried under the ash. Does this happen in our world? Absolutely. There are fossils forming now. Absolutely. But at such a small rate, at such a tiny rate. It would take, I would have to agree with billions of years to get the masses of dinosaur bones. But not just dinosaur, animal bones, plant fossils. It would take something much bigger than just the common things that we have today to get the fossil record that we have. So the record of change as the organism has evolved through history is recorded in the geologic column. So let's take a look at this. This is in a textbook, science textbook. T-Rex dies. Gradually his soft fleshy parts rot or are eaten, and he gets slowly covered with dirt. The dirt gets thicker, he fossilizes, then it erodes, and some scientist finds the bones. Nice try. Nice try. What's going to happen to this guy while he's like that? Somebody else is going to come along and grab a leg or a femur or something and take it with them. Chew it there. Dispersal of the bones. Did you know that even bones get eaten by mice and rodents? That's their major source of calcium. There might be a big bone left to become a fossil, but this doesn't happen. Sorry. It doesn't happen. In order to get a fossil, you have to have a rapid, deep burial. Rapid. Because you can't allow it to decompose. If bones start decomposing, the collagen, bones are made of two things. Collagen, which is a lot like cartilage, and then calcium. So if you've got acid rain, the calcium is dissolved and washed away, and the bones just go to nothing. If you have the cartilage, if there's bacteria growth there at all, the bones will be... Listen, all the creatures that have lived on Earth, where are they? Well, most of them died like that and were eaten or dissolved. I mean, if you go out and after, sometimes I'll go walking in the woods and I'll find a skeleton of a deer or something. And it's never pristine. It's always chewed on and dissolved. Brittle, very brittle, and goes to nothing. I'm going to keep going rather than take any questions at this time.
Sure.
Is that be right? Okay, so here's a good way to explain the geologic column. That's Noah He's saying, go and bury all this mess, and don't forget the proper order. Archaea biota, then near the bottom, then trilobites, then dinosaurs, and finally the big mammals on top. But Dad, it's going to take millions of years. I just love that. Okay, so let's go through this list. Okay, problems with the idea that this system could produce the fossils. The consistency of the geologic column. It is so consistent. If you go and find a chunk of it in Africa, and a chunk of it in South America, and a chunk of it in Greenland, it's like, how can it all be the same order? Too consistent for some bit-by-bit formation. Number 2, it's worldwide. Number 3, vast deposits of fossil fuel. I spoke about that. Coal, 10 to 1. There are coal beds that are like 200 feet thick. So that would require vegetation that is 2,000 feet thick, buried under a mountain so that it will be squashed with heat and pressure, extensive pressure, so that it will form into coal. That doesn't just happen naturally. I mean, Mount St. Helens blew its top back in 1982, right? Blew all the trees right off the side of the mountain. There would have been some coal formed, but no, those trees didn't get buried deep enough and rapidly enough. Most of them either were waterlogged in Spirit Lake or rotted on the surface. No coal formation. No, it's going to take something much more extensive to produce the fossil fuels that we have today. The smooth boundaries, we talked about that. This one, polystrate fossils. This is an interesting issue. This is a fossil that is in more than one layer. For instance, in California, there are whale fossils. And the whale fossils, the bottom of the whale fossil and the top of the whale fossil go through about 5 million years of evolutionary time. Now, you tell me what whale is going to lay there and not rot for 5 million years while it gets covered enough to become a fossil. There are trees that go through about 15 million years worth of layers. Trees rot a lot faster than 15 million years. And no, they weren't growing during the time. They're broken off on both ends. There's just so... What you're going to find out is the more you learn, go and start studying this stuff. The more you learn, the more you'll realize how ridiculous and impossible this thing is called evolution. Don't be afraid of it. Most of the people that are the loudmouths know the least. Honestly. Just won't do. Extensive bone beds. There are places where there are literally thousands upon thousands of creatures accounted for, all their bones in one area. Now, in some cases, they're laid upon each other, complete skeletons, but there are bone beds that are like 30 feet deep and 300 feet long and 200 feet wide.
Graphite.
Yeah, that are just pieces of a billion different dinosaurs. I know I can't imagine some big, saber-toothed tiger bringing all his, catches to one spot, and after his 5 billion year lifespan, he's got all these bones. No, because they're sorted. What can you think of that would sort bones and wash them all? Sorry, I gave you a hint, didn't I? Wash them all to one area and then cover them with silt until they were deep enough that they formed into fossils. Yeah, water. Once again, we have some that's pointing to the flood. And then, of course, lack of transitional forms. Evolutionists will say, bah, 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 bah. Don't let them away with this. So, wait a second. You're telling me, have them tell you how evolution works. So what do you start with? Okay, and what does that turn into? Have them go through it, and then just pick any gap and say, okay, so shouldn't we find... And they'll start backpedaling. Well, maybe that was a time when there wasn't any fossils forming. Wait a second. You believe in uniformitarianism, right? Which means that all along, if we have any fossils, there should have been fossils being made all along. You see how you can use their pronouncements against them. Okay. Let me tell you an explanation of why the geologic column starts with simple life forms and gets more and more and more complex. This, I didn't come up with this, but this is the best explanation I've ever heard. Let me tell you. Think flood, okay? What is it? The fountains of the deep broke open?
Yeah.
Windows of heaven broke open?
Yeah.
All this water starts falling on earth. What do you notice about water? It runs to the lowest place, and so the flood would gradually rise in elevation, right? As the water accumulated. Okay, look at this. What's the first area that's going to have lots of wave action and deposition? Deposition means eroded materials dropped. First area is going to be the lowest area. That's where the water is. Then, as the water starts beating on the land, it's going to be in swampy areas. That's going to be the next highest level, right? It's going to get inundated by water, sloshed around, eroded, and buried. And then it's going to come up a little bit further. And it's going to be your mangrove swamps. It's going to be your lower elevation. It's going to be your tropical zones. That's going to get inundated, eroded, washed away, and buried. Now, as the water is coming up, the animals that are best able to locomote, in other words, run for higher ground, are going to be on their way. But any animals that are not able to move quickly or move away or swim are going to be captured by the water as it's rising and washed into these huge deposits. As the water continues to go up, it's going to get the smaller mammals that can't run that fast. Maybe at some level, all the cold-blooded creatures who are getting doused with this freezing cold rain are going to, cold-blooded creatures can't take off. So they'll get buried next. Maybe the feathered creatures will get buried next because they have gotten so doused with rain they can't fly anymore. And then next, and gradually, if you think of it, this biome succession. The first biome would be the aquatic environment. Next biome will be the swamps. Next biome would be the lowlands, tropical zones. It fits. The vertical biomes fit the geologic column. At the very bottom are going to be your single-celled creatures that are too small to move fast enough to get out of the silt that is deposited right at the beginning of the flood. Next comes your clams that they can swim a little bit, believe it or not, move a little bit, but they can't escape. And then come your swamp creatures. This fits. And there are a lot of scientists that look at this thing called biome succession and the flood record, the geologic column, and they say, whoa, geologic column is not the record of evolution. It's the record of biome succession as the floods rose. Who's way up at the top? Mammals. Mammals who are able to generate their own heat. What's below them? Dinosaurs. Now, we're not really sure if they're warm-blooded or cold-blooded, but they're so much like lizards.
Yeah, but wouldn't by the time it got to there, it'd be so saturated and they're so big, they'd get stuck in the mud. They couldn't move. They'd get the same problem.
There's so much evidence that just puts it, well, good thinking.
Yeah.
Well, good thinking. So, plants and animals in each biome were buried successively as they were deposited and covered by particulates. It fits. It fits. It makes sense. So, the geologic column is not the record of the evolution of life, but it is the record of the rapid deaths and fossilization of billions of plants and animals in a worldwide hydrologic event. Oh, I love that! The flood! The flood, okay, the flood doesn't explain everything. There are some things in the fossil record, there's some things in the geologic column that they puzzle flood scientists just like anybody else. But the vast majority of what we see in our world, millions of fossilized organisms spread across the world. Now, when I say across the world, where do you find fossils? Everywhere. Everywhere. Oh yeah, oh yeah. You dig long enough, you're gonna find them. Now here's, I know it's too late, isn't it? It's 8:40. I need to be kind. So what we're gonna do, I haven't even gotten to the good stuff yet. Tom, you're just shaking your head. Tom keeps telling me, cut it down, Tim, cut it down, but I don't know what to cut out. Tomorrow at 3 o'clock, right here, I'll finish this one. And it's probably the best, from here on is the best, because I just show you pictures of fossil after fossils after fossils. Dinosaurs are not the only fossils. There are fossils of everything we have now. What does that mean? That means that the creatures we have now have been around for a while. There's fossils of them. Fossil birds sitting on nests. Fossilized. So it helps us to understand that we're not at the peak of evolution. We are part of the record of Earth. So tomorrow at 3, I'll do the rest of this section, and then at 7, I'll do the last section.
There has been floods since the beginning of time, right on?
Yes, small floods.
That's right.
Yeah, small floods, but only
This
one.
isn't anything unusual. This isn't anything, there have been floods ever since the beginning of time.
Not the flood that destroyed.
All right.
And then at 7.
Bring your friends. It looks like we've got extra room. Bring your kids. Bring your nephews, nieces, neighbors. Kidnap somebody, bring them. Well, maybe don't
Bring
kidnap.
some fossils tomorrow.
You have some fossils. If you have fossils, bring them. We'll show them
The
around.
most amazing conglomerate rock
Ah,
that my
That'd be
granddad found in the desert in Arizona.
Neat.
Beautiful.
neat, neat.
It's
Thank you for tolerating my long-windedness.
Oh, we
If anyone has questions or wants to see some of the fossils that I have,